Yes. So welcome to tonight's MDriven session. I wrote on the invite a few things about load balancing and things that we have done in order to better prepare ourselves for the requirements that we get from different clients that's going that has maybe more requirements than we have had before internally and when we set up the systems. And it's primarily failovers for the MDriven servers, and normally everyone's using clustered databases, and that when we run on Azure SQL, that's clustered, and we don't really need to to think about how that's done. It's just included in the service, so that's all good. But when it comes to the machines, there's several, and certainly when you do your own physical or virtual machines, probably virtual machines, and you set up them all by yourself, and you have a lot of network rules, and you have large corporations that sort of have departments specifically tasked to do firewalls upgrades and things tend to stop working from time to time, and things tends to get cut off. And one maybe the organization is set up to have two places for servers, and one of them is offline or taken offline for practice, or just because someone did something wrong. And then of course it's good to have failover strategies, and we want to be able to work with the normal reverse proxies or firewalls to handle such load balancing. But there's a few considerations that we need to think about on doing that. And I know you, Lars, you have had these needs on the Sci-Free project to put up more front ends.
Yes.
And front ends is fairly straightforward to just add more, right?
Yeah, you could say that. I mean, at least it's easier because there isn't a single point. And yeah, so easier, though that I think the tricky thing is to scale at the right time. And we also are going to make some more improvements on hot loading. I mean, I think we need in the future to have a way to get a server ready. I mean, starting the server and doing these things until we tell the load balancer to put traffic towards it. And we don't have a built-in feature for that. So today that would be a lot of extra.
And the basic idea is that there's something in the front having one open address and one name, and everyone talks to that, and this load balancer receives the traffic, and depending on the setup, routes it to the correct underlying server. And what's important for the front ends is, of course, that the sessions are what we call sticky. That have you started getting traffic to one of the nodes in the cluster, then you're supposed to continue with that node until it breaks, or until your session is terminated and you do something else. So that's the important thing for the main turnkey front end load balancing. Let's see if I can share my screen, and I just figured out that might have been doing this setup wrong. So, and we're gonna switch to this one and run the click once. So, something like that. You see my screen now, right? Good. What we always do when we do something new is write a wiki article, load balance, and this is, we should fix this so that it searches. I know we have fixed it on some other clients of ours that use the MediaWiki to have a better search engine, so it doesn't miss this but gets a hit on this.
We have the better
one. Yeah,
but
we had it, but I think it's sort of fell off. So load balancing the Turnkey server. So the important thing is to use sticky sessions to return to the same session, so we don't confuse the user with the creating a new session. And then you might have the need to suggest to the load balancer if a node should be active or not. Let's say that you have 5 nodes, but you only want to run the load on 4 of them. So the 5th must somehow say that it isn't available. And the load balancer is typically some configurable to get a URL with an expected answer. And it will run this URL towards the nodes and see if it gets the expected answer. And the simplest thing is that it doesn't get an answer, it gets a timeout. And if it gets a timeout, it will definitely not send traffic to that node. But sometimes we want to take it offline without actually removing the node, and we still want it to answer on traffic because we want to work with it, but we don't want it to be part of the cluster. So then one good idea is to do simply in your model, do a view model with rest allow and with no access groups or something like that. Just let it go right through and give that URL to the load balancer and send back the data you have agreed upon. And well, you could return just a string active or inactive, and then you could have something in your application to signal this. But I wrote this 2 days ago, and then it dawned on me just today that this will not suffice. We will need to do something, because almost every a single front end will not actually know which node it is itself. It must be able to, well, I guess it could read the IP address and something like that. And that, yeah. But so I think we might need something more, or we will turn off the whole cluster.
And there's where I would like to hook in, there will be more examples coming up there for if like if you look at Azure, it will at a certain CPU level, for example, it will instantiate a new server with actually the same name and the same file. So that's what you're pointing out, Hans. Like it's different to tell which one is which. So there might be a built-in feature to access the underlying server and say, which instance am I? Maybe in OCL or somehow otherwise. And then also this, that you can detect. I mean, you can do that today, but a system for doing it to say, like, everything is now loaded into memory. I am ready to take traffic, and then you switch it into active. Because otherwise, the first client that comes to it will find it slow. and then the switching onto a new client will feel bad.
Yeah, so some kind of warm-up phase where it's okay it's online, but it's still not ready for load. So that kind of configuration is possibly something that you will want to do in your load balancer, but then your nodes need to be able to answer these questions that we define. And all questions will be asked via HTTP or HTTPS, and that's also a thing to consider when doing load balancing, because we have always done everything over HTTPS, but when being behind a reverse proxy and being inside a server farm, protected server farm, one could gain a few microseconds by ignoring the SSL, and one can also possibly have some cache benefits in the hardware by ignoring the SSL and terminating SSL in the reverse proxy and letting the traffic go unencrypted through the network on the inside. So that's not something that we currently support. Our service will try to switch back to HTTPS and say that they don't feel comfortable, but we will probably allow for HTTP only in these scenarios. So when it comes to the core servers, they are HTTP just to avoid the hassle with setting up certificates for doing simple testing yourself.
Can I point also to an important factor there is that in many cases when you have load balancing or you have servers internally, your certificate situation will be difficult if you require HTTPS, because then you have to have a certificate that probably works with outside SSL, and then your internal servers are calling also, and you probably have a different name lookup world on the inside of your firewall. That's another reason for this coming.
Yeah. So and that information should probably be on this page as well. Let's see. The information regarding the override of the server URLs. I'm not sure if I'm gonna find that now when I search, but hard server URL, because yeah, now I should really have something to draw with, but I'm gonna bring up Paint, I guess. So if you have a let's say this is the reverse proxy, and then you have two TK servers here in a cluster, and this one loops. There's traffic coming from without, and it's going here or here. But this will sort of communicate with itself from time to time. You will do REST lookups to yourself, maybe for reasons and things like that. So there's a question if the URL that this should know about itself should be this, or if it should be this. And sometimes it's very opportune to let it talk this way instead of letting it talking this way. So then this hard server URL comes into play, a way to define what the local address should be. This becomes particularly obvious when you think about that you have an MDriven server in the end serving both of these, and when changes come from one user, it is noted, and this has a small memory cache on what objects has been going through the system and who's looking at what. And then there's a signal R call that will go back to the subscribing server. And of course that could go all the way up here, hoping to find its way down to the correct node. But it's much better if this one has signal that it has its own name, because then such a call would go straight to that one or straight to that one. Because the signal R works like an open WebSocket, and it's always the receiving end that initiates the couple. So this turnkey server will initiate the WebSocket and connect it to the MDriven server's WebSocket server, and then hold that open so MDriven server can talk back. Yeah, I guess it doesn't really matter if it's open that way, it will always go here. I'm not sure. So we have had a lot of issues doing setup with reverse proxies when it comes to WebSocket, because I think the reverse proxy guys, the one that owns the firewall, sort of pours cement into this one and then some epoxy, and then they put it on fire and then they're done. So it's pretty much locked and destroyed for any kind of network traffic.
It matters a lot because a firewall always have a port, an open port list. So you need usually the firewall, if there is a firewall, it usually doesn't allow you to send packets if you haven't opened it from the right end. So usually here the front end will be able to make one connection to the MDriven server. That session is then stored in the firewall. So to know how that return packets from that session is still allowed to pass.
Yeah.
So it's the state table of the firewall.
Yeah. We should bring you into Finansinspektionen. I hear that, because I don't think they've managed to sort it out yet. What happens with Signal R, and why it's Signal R is it's a high-level abstraction and an open source package on real-time communication. So it's much better than using WebSockets straight off, because Signal R, when it detects that whoa, WebSockets won't work, I'm not getting any progress, then it does fallback techniques, and one of them is like a long pole. So that's a normal HTTP or HTTPS call that won't be ended until there's something to say. And when we set it, they open a new one. So that's a fallback for the communication of, so we get the real-time feel anyway. And I think that's what's happening on the setups that has these issues with the where we have the problems. Yeah, good. Yeah. Moving on a bit to load balancing the MDriven server. So in this case, maybe we should look at this. So if this is the MDriven server, it's a what you would call a single point of failure, and that's really not that dramatic because there isn't any state in this. Well, the state that's here is the server-side jobs. So there's a list of server-side jobs that will execute on this level. And of course, we don't want it to stop, but any traffic coming through here is formulated with in the perspective of the model, and then the model lives here in MDriven server as well, and converts that to whatever persistence mechanism that is in play at this point. So usually MySQL or SQL Server, and most usually SQL Server, and also you can do like Oracle and things like that. So there's two real jobs for the MDriven server. It's being this persistence mapper, being able to turn every model call into a real SQL call in the end to the database. And that's the first job. The second job is to watch this list of server-side jobs and run all the queries on those to see if there's anything that triggers and should be done. So, and if so, it should do it. So this is central to functions like this is async tickets. That's really a quick way to get things alive and moving, and side effects of other actions. And also central to things like cache invalidation to detect changes to complex structures in order to invalidate them and refresh caches really efficient. So we definitely don't want it to not be available. So if this lives on a particular hardware server, being it virtual or real, and that one goes offline, we would like to have another one prepared next to it, being like a hot swap, being not active but available. So the load balancer that we put in here between these knows that this one is the one that we're going to use, but we also have this one. So in order to define that, we need to usually set the load balancer in a failover mode. So that's another way to configure the load balancer. So here we were on sticky session, and typically round robin you call it, when you just pick one of the servers in the list if there's no session information, and then you will load out the sessions over all the available servers. But that's not the case for MDriven server, because one important aspect is that there's only one that runs these jobs, because these jobs are frequently jobs that we definitely want serialized, like handing out a unique number from a list. And if there were two guys doing that same job, it wouldn't be serialized. We couldn't ensure that there's only one guy handing out the keys. And if there were two doing it at the same time, we could not be sure that it would be sequential. There could be scenarios where the one unique number is handed out twice. And of course, as a junior developer in your early 20s, you always think that this will almost never happen, so maybe we don't need to worry about it. And if you're 21, you have seen that it happens all the time, and that you should really be have check on things like this. So no sticky session and no things round robin on this level. It needs to be a failover. But being a failover, it's really important that we can configure this reverse proxy to use one and the same, and the one that is picked for usage should be the one that runs the jobs. If this one isn't picked for usage, it shouldn't run the jobs. That's equally important. But it still should be able to, we should be able to communicate it with it somehow, because we will need it to manage it and do config on it, etc. So it needs to be turned on, but it shouldn't run the jobs. So that's the main additions that we have added this past week in order to get this done. We can try to upgrade our... Okay, I lost them. I'm gonna add a server pair here, and I'm gonna download the latest ones. So the local servers is a really neat way to simulate a full stack on your... So now I've downloaded them locally, the latest versions, and now I can refresh the install for server 1. And once I've done that, it suggests these port numbers, and then I will be able to start the servers. When I get these kind of crash dumps in the startup, I haven't really figured out what's the root cause, but there's some file lock that we get for writing these files. One workaround that I've found is to actually just do another pair of servers, and then this one, I think it's like the virus protection or something that goes into and reads the files, and when I put in another pair of servers, I confuse the virus detection and it moves on to the next pair, and then these are free. So the first pair started without problems now. Can't really explain it any other way. So getting this address and heading back to a browser. So this is sort of expected reaction sometimes when you download a new version, because what happened now was that the schema on the database was old, and we need to get it updated. As you're gonna see that I actually have the MDriven server. So so that's why after you install a new version, you should always access the UI, because it's in this UI access that we try to do. Basically, I'm going to show you. Never. I've said never like a million times, but so what we typically do is this evolve administration database, because as we evolve the schema for MDriven server admin data, it needs to get an updated database, and we just let the application run into the first error, and if it runs into an error in the UI, we try to do this, and then it says then it changes the schema. That's the same thing as we do when we upload models in normal or apply evolve to models in a normal settings. But this is then for the internal system in the MDriven server, which speaking of that, is easily found here, data in admin. So here you can see the whole all the classes available in the administration part of the MDriven server. So we can, for example, see the server-side view models, and here they are apparently free server-side view models that has been created for us, or that we have created at some point. These sysasync tickets are part of the pattern, so they have been created for us then. And those are the same that will show up if we look for periodic actions. So I've noticed that we have a sort of name discrepancy. Sometimes we call it periodic actions and sometimes we call it server-side jobs and etc. But it's all the same thing. So here we see those free server-side jobs. So what we can also see here is that if these are running, and then we would see these red dots whenever they try to execute the criteria on them, and we can see that they seem to be running. So what we want to do on when it comes to load balancing is go to users. I'm not sure why we ended up having it on users, but it ended up here. So here is some settings from before. The name of the server, so this server is named new, and there's a new setting for that if you check this one, it will actually, before starting the server-side job task, it will check if the load balancer returns our name. So that's the strategy. So what we would need is a load balancer, but we can just simulate that we have one and say that we're going straight to ourselves. So what we will do is check the load balancer and then home return node name if okay. So if we take this on a page, yeah, that wasn't what I copied, but if okay, we see that this server will return new, and that little fact, and if it would have another name, newer, I will need to press submit to since this is an MVC thing, and this would return newer. So that's the name just coming back. So what we can do is hand this configuration to the load balancer, that you're supposed to check this whenever you can, as often as you can, and the valid results should be newer 1 and newer 2, say, or newer and even node 1 and node 2 probably. And as long as you get that, that's okay. You can choose one of them, and the load balancer will then just pick one of them, and since it's a failover, it will leave the other one alone. Once it has picked one of them, we can ask ourselves from the MDriven server, can we ask the load balancer, which one did you pick? Just by doing this call on the load balancer, because we will get back a name as well, and we will get back the name for the active one, for the hot server. So knowing that the name of our node should be the name that comes back from this call, we know that we are the one that should run the jobs, and that is what this check does. So that's a really simple way to let us have control on who's running the jobs. So we need to instruct the MDriven server because there's a little bit of overhead of doing this check, so we don't want it if it's not needed. And this check is also only done every 30 seconds, so there will be we will see if that's enough, but potentially it will be a small gap in production when the load balancer switches. But keep in mind, it's only the server-side jobs that are affected really, so it's only a problem for us doing these periodic tasks that they will be delayed 30 seconds, and that usually isn't a gigantic problem. But we can talk about what time to set there. I don't want to add too many settings because settings just confuse, and putting up a setting always has the projection of it being really important and it being something that you really should understand, and I don't think we need to worry about it. But then again, from time to time we want to have this the load balancer has chosen our node, but we want to force it to choose some other node instead, because we're gonna do service on this, gonna do some configuration, or we're gonna restart this this hardware or something like that. So it would be neat if we could have an easy way to signal to the load balancer that it should leave us alone. And what I came up with was this button, hide server from load balancer. So if I check that one and submit the value, so, and also this one, load balancer status. So this is what the logic has come up with so far. Will run periodics on this node. But as we check this, this will actually return something else. So it returns the name and appends this. This node has requested to be left alone. And then it will not match the two values that we have defined in the load balancer. And then it will assume that this node is down, shouldn't be used, and it will then fail over to another one in our list of open nodes. All the nodes that return their own name, and we know the names in the load balancer, should be okay. But this is not okay. And if I refresh this page, it's the load balancer current status is will not run periodics here. Yeah, because and then it says where will it run then, and since we've just faked it, we didn't really have a load balancer, we just said ourselves, so it assumes that there's a server in this case that's called this, and it will go there, but that won't happen. So that's a fairly low impact configuration that makes it possible for us to set up 1, 2, or 100 MDriven servers that are hot standby if we think that that's needed. So maybe we should say something about what if one MDriven server as a single point of failure is not enough. Maybe we are Facebook and we are running servers for the world. Yes, and then is probably a different scenario altogether. Probably there is not one system, it's multiple systems acting as one. And each system has its own MDriven server. So that would be fine. But then that goes into on the model level almost, that you know what the super system is built of many subsystems. And that's something that you would define in the application logic on how that would work. However, if you're in the middle ground, maybe you're not Facebook, but you're not one firm or one area application, you're somewhere in between. Then we have the concept of slave servers that we recommend heavily, and that goes into setting different modes on the server. So this server is set in normal mode, and you can actually set a read-only slave, and the read-only slave is connected to a master server. And whenever things happen, something is written in the master server, that's stored in a transaction log in the database, so it's backed up with everything else, and that's quite easy to make sure that you have that table available. Just press this button, and that builds up the transaction log that everyone that's a slave, all MDriven servers that are slaves, will frequently ask the master server, is there anything in this log? And you can even chain them, so the slave server doesn't necessarily need to ask the master server, it can ask another slave server. Of course, data will flow from one slave to another slave, and that will impose a little bit of delay. So this is a really easy replication strategy that will work 100%, and it's also really neat that once you upload the model, refresh or evolve the system on the master server, and you do development, the slaves will discover that, whoa, the checksum for the model isn't the same anymore, and it will pull the model from the master server and evolve itself. So it's really a cool self-playing piano, spreading your new version around the world, and letting your clients that work towards your local copy or a regional copy as a slave having really low latency and delivering quick. So that might be exactly what you need. But then again, these locals, once they want to save something, what's going to happen then? So if you try to save towards a read-only slave, it will actually route the data being saved to the master server. So there's still a bottleneck in the number of writes that can be done. So that's why I say it's not the Facebook solution. The Facebook solution is to understand how to divide the large system into subsystems. And
yeah, I just want to point out also a different aspect of this. So you can also think of it as the master-slave system will ensure transactional integrity. So you will only have one that is running server-side job, the master, but there will be transaction integrity, which means that you will only do unique things in one place because the master is the only one acting on your data. So it's a way to improve performance for read access. And actually today with it's not that far. We've actually run MDriven system and they feel okay even from Australia to Sweden, which is actually not that bad without the slave server. So if you put up slave servers in different geographical regions, the save delay is usually less than 1 second. So, but what you could say is that it means that you can get kind of the best of two worlds. Because the problem if you try to set up there's been this idea from SQL, like the SQL companies like Microsoft producing the SQL server, that you can sync SQL servers. But usually that's a bad idea because it fails because you have like two worlds that are not really compatible. You have the idea of transaction integrity and all that going for you, but then you haven't modeled for it in your application. So it's always a mess to figure that out. So our recommendation is either you go for the way with master-slave, because you have usually 100 times more reading than you have writing. So you can have full transactional integrity and the saving is like 1 second. But it's also important to note that what happens is that when you save, let's say you're saving in Australia to the local server, your client has the data, it's just saved. So, I mean, you will feel that it's there. What happens is the save goes all the way to wherever the master is, and then the notification of the data coming back is the same way. So usually the client won't feel that they haven't saved, right? As long as there hasn't been a problem saving or someone else have saved the same thing, it will come back the same thing and they will never notice that there was actually a second delay in the actual saving all the way. So that's a way to attack this problem. And then the other way is, as Hans described, is to model this thing properly. I mean, so that your model is aware of that there are multiple data stores and they will synchronize in between them. And that's basically what we are talking about when we talk about Facebook. They have eventual consistency, they say. Well, what is the eventual in eventual consistency? Well, it's actually that the nodes are syncing with each other. That's the eventual, that they finally end up being in sync with each other, which is basically that they've modeled, you could say, the synchronization mechanism. Then there are, databases that does this automatically, which is kind of true, but has the same issues with the SQL Server. Because what if you have 2 rows in an invoice? Well, that doesn't matter because that's not how Facebook operates. So if you have a very simple data model like Facebook do, and you synchronize using GUIDs on your different posts, it's not a problem. But if you have an invoicing system, you can't really rely on people being able to just save rows into something.
Yeah. So sorry, continue.
Mm-hmm. No, there was one more thing, and that's about, so how do you model really good to avoid the things that goes into, for example, an inventory stock level. Let's say you have that problem. There's actually no good solution even with a SQL Server in one place and even on a local network, because let's say you have 100 users all selling the same very nice thing or an online web shop. There will be so many that wants to update that single summary of how many you have in stock that there will, eventually it will break down. What's the solution? Well, don't update. Okay, well, I have to update, right? Well, yes and no. What you do is that you have the article, or you have the stock level of the article, and then you model an additional object that says how many you have taken, the deltas, right? So every time you do something, you save the delta, you add deltas. And because we are on the MDriven server and everything is subscribed, you can then put a field that says take the total value and add the deltas. Great. Then you have that automatically updating all the time. And it doesn't matter how quickly they go in there, you'll have a good delta going. Right? And then every time you do this, you have a server-side job that periodically take the deltas and apply them to the summary. That way, you have a lazy sum feature in your central server, and you have a very rapid way of getting it. And then you have server-side again, you have a feature that allocates if your order actually went through. So by just modeling differently and having a lazy reader in the background, but using also the subscription of delta values, summing up to the thing. You actually get something that can be distributed. It can be transactionally safe. It can be distributed worldwide, and it can use master-slave technology. And it's actually quite efficient. So just, pointing out how
Yeah.
you scale.
And I just wanted to say, doing Facebook, you need to accept that Facebook can never ensure that they hand out a unique number for sure. That isn't a GUID, of course, because that's made unique by algorithm. But if you are going to count out 1, 2, 3, 4, that won't be able to ensure that someone in Peru doesn't get 5 and someone in Tibet also get 5. Because it's eventually consistent, and eventually we will find the problem, of course. But the thing with this kind of systems are that there never should be a problem. You can't accept that there's sometimes a problem that we will eventually fix. So there's a difference on how fast the information are supposed to flow, and if we should always agree on facts that we need to take into account when doing what kind of system we are building. So we're not saying that you can't build certain systems with MDriven. On the contrary, you can build anything with MDriven, but you still will need to maybe take into account that this system that you're building is eventually consistent and thus can be spread into 1,000 subsystems. Cool. We have actually...
Derek seems to be... There's a lot of cogs going on in Derek's mind, it seems. It's like, really?
Yeah, well, I mean, not my area of expertise at all, but I'm learning a lot. And what I'm thinking is, I'm trying to think of, other sort of systems like, I don't know, airplane seat designations or other kinds of systems, and the sorts of approaches that they would take. They're kind of betweeny type systems, and whether how much the logic that you've described is proved and tried and trusted, and which kinds of systems use that kind of, as you call, lazy synchronization or whatever or whatever term you use. It's pretty fascinating, but it's certainly not my area of expertise.
Yeah,
but, I'm thinking about it. Yeah.
So
if you don't have one single thing that handles it, you can't update the one thing. That is destined to fail. So then you need to come up with other ways that basically adds to the thing, and then you can't be sure until it's been processed by the one node. So in this scenario, that's why I thought about this whole thing. Hans talks about failover, MDriven servers and stuff, and it comes into this that there's no such thing as at the same time. Everything, I mean, in one machine you have an atomic operation, but then a lot of the times, and I've worked with bookkeeping and stock inventory and all those things, and there's simply no way to keep it going. So, and usually you see that also when you reserve a seat in the booking of an airplane ticket, right? And then at the end you can still add, oh, sorry, that was gone all of a sudden. It's like, whoa, how did they keep track of that, and why did I lose it? So they add these reserve things at a temporary level, you could say.
And then they wait for... Yeah.
And it's either killed off by the system in the central system, and then it's freed again, or it's actually confirmed, and then it goes into the confirmed thing and deducts from the total. So I just, when you talked about this, Hans, I just felt that this could be an interesting aspect of the whole thing, because this problem comes at every level, right? Here we're talking about the front ends to one back end, then the back end becomes multiple back ends, and then in this case, then we scale with multiple MDriven servers in layers, and we have discussed this a lot, Hans, and I said it's like, let's not go down the route where we try to synchronize everything, because that will
Ah.
always fail.
Yeah, that will never scale.
You
So
have one point of saving, or you model it somehow.
yeah, and
Because I've been down this route, and
so you can easily think that you do Facebook like 20 different systems that sync really slow to, because the ones in Peru very seldom are friends with the ones in Tibet, and they are not awake at the same time anyway, so they won't notice the lag. Then you have a thing where you sell tickets as well. So that's a totally separate system, the ticket selling system. That's slave master based, and it's really tiny amount of data and no pictures and nothing. So that won't be a problem to have that way. And then you sort of coordinate it in one sort of experience, user experience. But we're out of time.
sorry.
So thank you really much for showing up and discussing with us and seeing what we do. And we will be back in 2 weeks with something that we don't know what it is today.
Okay. Thanks very much.
Okay.
Thank you.
Thank you.
Thank you.
Thanks. Bye. Have a good rest of the day.
Yeah.
You too.